Hello Algebra 1 students, this is Mr. Wilsey, and in this video we are going to be refreshing your memory on solving linear equations. Now I know that this is a topic that you've studied in middle school math before. You might be really good at solving equations, but I just want to make sure that everyone has the same foundation, which is why I want everyone to watch this video and the subsequent videos, and as with all of my videos, I want you to be taking notes on paper as we work through some problems together. Okay? So let me just give you a very simple example of a linear equation. X plus 5 equals 12. Now if I asked you to solve that equation, what does that mean to you? Well, I hope that it means to you, let me get my face out of the way, that I'm asking you to find the value of the unknown that makes the equation true. So let's break this statement down a little bit. What do I mean by value, first of all? Well, value is just a number, all right? Then the unknown, in this case, the unknown is x. So our unknown is represented by a letter. We could stick in any number in for x, right? We could replace x by any number, but there's only, in this case, one number that we could replace with x to make the whole equation true. Now in middle school, you began to learn a process to solve linear equations. And this process involves isolating the unknown. Now, in order to isolate the unknown, in this case x here, we have to look at everything on the same side of the equation, in this case the 5 here, and we have to figure out a way to move it to the other side of the equation. And the way to do that is to do the opposite of what you see. So in this case we are adding 5 to our unknown. So to move the 5 to the other side of the equation, we have to subtract 5. But we have to make sure to subtract 5 from both sides of the equation. Now, look at what this does over here on the left side. We have a plus 5 and a minus 5. Those cancel out, leaving us with just an x on the left-hand side of the equation. And then if we do this math right here, 12 minus 5, we find that 7 is the value that makes this equation true when you stick 7 in for x. So that was a pretty simple example. So I'm going to put 4 equations that I want you to try to solve on your own first, and then we'll work them out together. So the first equation is j plus 9 equals negative 4. Second equation is negative 7 equals k minus 3. The third equation, negative 8 times n equals negative 64. And the fourth equation is 14 equals z divided by 2. All right, let's look at equation number 1. So we want to isolate the unknown, which in this case is represented by j. So in order to isolate the j, we have to move the 9 to the other side of the equation. In order to do that, we have to do the opposite of what's currently happening, which is that we are adding 9. So we have to subtract 9, just like in the previous equation. So j is the only thing left on the left side of the equation. Negative 4 minus 9, we can replace that with negative 13. Okay, so we've solved that equation pretty easily. Now let's do number 2. We want to isolate the k, so we have to move the 3 to the other side of the equation. Right now we are subtracting 3, so in order to move it, we have to do the opposite of subtracting, which is adding 3 to both sides of the equation. So we are left with k on the right-hand side of the equation, and then negative 7 plus 3 is negative 4. Now notice that the k is on the right-hand side of the equation, which is kind of weird Usually we expect it to be on the left-hand side of the equation, like up here, but that's all right. It doesn't matter which side of the equation it's on. All right, let's look at number 3 now. Now, a lot of students might be tempted to add 8 to both sides of the equation, but this is not correct. I can see why they might want to say that, but it's not correct. Why is it not correct? Well, because right here what we actually have is a negative 8 multiplying the unknown. So in order to move the negative 8 to the other side of the equation, we have to do the opposite of multiplying, which is dividing by negative 8. Now notice right here, we are multiplying by negative 8, and then we are dividing by negative 8. Those cancel each other out, leaving us with just n on the left-hand side of the equation. Now over here, we have negative 64 divided by negative 8. Since we have two negatives that are either being multiplied or divided, that means that the negatives cancel out, leaving us with a positive number. In this case, it's going to be a positive 8. All right, finally, let's look at number 4. Our unknown z is being divided by 2. So in order to move the 2 to the other side of the equation so that we can isolate the z, we have to do the opposite of dividing, which is multiplying both sides of the equation by 2. Divide by 2 and multiply by 2, that means that they're both canceled out, leaving us with just z on the right-hand side of the equation, and then 14 times 2 is 28. All right, so I hope that this was a quick review for you, but hope that it was also still helpful. Let's go on to some more challenging equations, and I want you to try to tell me what is more challenging about them. So let's look at this one first of all. 2x plus 3 equals 15. So what's different about this equation? Well, I hope that you recognize that there's going to be 2 steps we have to take to isolate the x. We have to move the 2 to the other side of the equation, and we also have to move the 3 to the other side of the equation. But now, unfortunately, we have a decision to make. Which one do we move first? Now, I really don't know the best way to teach how to know which one to move first. One way you can think about it is that you want to try to work your way in toward the unknown. So start by moving the things that are farthest away from the x, and then work your way in toward the x. So in this case, I would say that the 3 is farthest away from the x. That means we're going to try to move the 3 to the other side of the equation first, and then we're going to find a way to move the 2 to the other side of the equation. So I hope that that rationale kind of resonates with you. So how do we move the 3 to the other side of the equation? Well, right now we are adding 3, so we need to subtract 3 in order to move the 3 to the other side. Right here, positive 3 minus 3, that gets canceled out, so we're left with 2x equals 15 minus 3 is 12. All right, now we have a 2 multiplying the x, so we have to divide by 2. So x is equal to 6. All right, that wasn't too bad. It just required 2 steps here. And it also required us to know which number do we move to the other side of the equation first. And as soon as you get a lot of practice with this, you will know intuitively which one to move to the other side of the equation first. So let's look at another example. How about 5 equals t divided by 2 minus 3? All right, so we have 2 numbers that we have to move to the other side of the equation in order to isolate the t. We have to move the 2 and we have to move the 3 to the other side of the equation. Which one do we move first? Well, using my rationale of working your way in toward the unknown, it looks like 3 is going to be the one that we move to the other side of the equation first. Right now we're subtracting 3, so we have to add 3 to both sides of the equation. 5 plus 3 is 8 on the left-hand side, and we are left with t divided by 2 on the right-hand side. And then finally, in order to move the 2 to the other side of the equation, we have to multiply both sides of the equation by 2. 2's get canceled out right here, so t is equal to 16. All right, that wasn't so bad, I hope. So let's look at two other examples that are slightly more challenging. Try to think about why they're more challenging. X minus 7 divided by 3 equals 5. Again, there are two numbers that we have to move to the other side of the equation, 3 and 7. Now, some students might be tempted to move the 7 to the other side of the equation first, but you can't quite do that. We actually have to move the 3 to the other side of the equation. Now, something else that might help here is to recognize that the fraction bar acts as a grouping symbol. So all this stuff on the top, there's really an imaginary set of parentheses around the x minus 7. So let's move the 3 to the other side of the equation. How do we do that? By multiplying both sides of the equation by 3. 3's cancel out right here, so we are left with x minus 7 equals 15. Now we can move the 7 to the other side by adding 7 to both sides of the equation, and so the value of x is 22. All right, let's try one more equation sort of like that. How about 6 equals 2 minus y divided by 4? All right, this one looks very similar to the last one, although as we'll see, it's a little bit different. So I just put the imaginary parentheses, made them visible, sprinkled my pixie powder on it. First step, multiply both sides of the equation by 4. 4's cancel out right here, and we're left with 24 on the left-hand side of the equation equals 2 minus y. All right, here what do you want to do? Maybe you might be tempted to add y to both sides of the equation, and you could actually do that. That would be okay. And actually, let's go ahead and do that. There's nothing wrong with ever doing this. As long as you do the same thing to both sides of the equation, you can do it. It's legal. So let's see where that gets us. 24 plus y equals 2. Now from here, in order to isolate the y, it's pretty clear that you have to subtract 24 from both sides. So the value of y is 2 minus 24 is negative 22. Now, if this step right here seems a little bit weird to you, try this. Here's another way to solve this equation as soon as we get to this part. 24 equals 2 minus y. Now, you might have tried to subtract 2 from both sides of the equation here, and that's also completely acceptable. So 24 minus 2 would be positive 22 equals negative y. Now, we are not done solving this equation because there's a negative sign attached to the y. How in the world do we get rid of that? Well, I hope that you remember that this negative sign here is really a negative 1 multiplying the y. So in order to move a number that is multiplying the unknown, in order to move it to the other side of the equation, we have to divide by that. So if we divide by a negative 1, this cancels out right here, leaving us with y. And then 22 divided by a negative 1, that is negative 22. And we get the same exact answer that we did before, except the y is on the right-hand side of the equation, but that's okay. Oh, I forgot to mention this is number 8 here. So now let's look at number 9. Number 9 is going to be slightly different from all the other equations that we've looked at. How about 3 over 8 times p equals 9? Now, what do you notice is different about this equation? Well, it involves our friend, the fraction. Well, let me rewrite this equation for you. Whenever you have a fraction multiplying, well, anything, but in this case, an unknown, you can rewrite this as 3p divided by 8. In other words, the 3 is multiplying the p, and the p is being divided by the 8. And it's a little bit easier to see what's happening when we write it like this. And when we write it like this, it becomes a little bit easier to see what we ought to do in order to isolate the p, in order to solve that equation. First step, actually it really doesn't matter if we move the 3 or the 8 first. It's a little bit easier to see how to move the 8, so let's do that. In order to move the 8 to the other side of the equation, we have to do the opposite of what's currently happening, which is that we are dividing by 8. So the opposite of that is multiplying both sides of the equation by 8. So this cancels out, leaving us with 3p equals 9 times 8 is 72. And then finally we have to divide both sides of the equation by 3. So p is equal to 24. And yes, I did have to use a calculator for that. All right, let's look at one final equation. I know you're probably exhausted by this point in time, but more examples that you see, the better. 20 minus 3h equals 2. Let's solve this equation for h. Now remember, try to work your way in toward the variable by moving things on the same side of the equation as the h to the other side, so that we eventually isolate it completely. First step is going to be to subtract 20 from both sides. So negative 3h. Please, 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 do not forget about that negative sign right there. A lot of students forget about that negative. It just disappears into thin air. So negative 3h equals 2 minus 20 is negative 18. Now here, do not add 3 to both sides. This is wrong. You need to recognize that negative 3 is multiplying the unknown, so we have to divide by negative 3 in order to move it to the other side of the equation and finally isolate h. H is going to be negative 18 divided by negative 3. That is positive 6. All right, that is it for solving basic linear equations. I hope this video was helpful for you. I'm actually going to bring my face back in so you can see me. Hello, I'm still here. Yes, it was me all along. I didn't, replace myself with a robot or anything to do this. Now you are ready to begin practicing and doing some more challenging equations.